In this video, we're going to focus on the atom, its structure, what it's made up of, and things like that. So let's begin. Let's focus on carbon. If you look at the periodic table, carbon has an atomic number of 6. It has 6 protons and 6 electrons. The protons and the neutrons are found at the center or the nucleus of the atom. Surrounding the nucleus, you have different energy levels. In the first energy level, carbon has 2 electrons. That's the greatest number of electrons you can have in the first shell. In the second shell, or second energy level, carbon has 4 electrons. So as you can see, the electrons are outside of the nucleus. They're orbiting the nucleus. Electrons carry negative charges. Protons, they have positive charges. Neutrons are neutral. So carbon has a total of 6 electrons. The 2 electrons on the inside are known as core electrons. And the electrons in the last, or the outermost energy level, are known as the valence electrons. So carbon has 4 valence electrons. If you look where carbon is located on the periodic table, it's found in group 4A, which is the same as group 14. Elements in group 4A typically have 4 valence electrons. Alkali metals, which are found in group 1A, contain 1 valence electron. Alkali earth metals, group 2A, contains 2 valence electrons. The halogens, which are in group 7A, contain 7 valence electrons. So you can find the number of valence electrons based on which group the element is located in. Consider the symbol He. He stands for helium. In the periodic table, you're going to see something that looks like this. There's a number on top and there's a number on the bottom. The smaller of these two numbers represents the atomic number. And the larger of these two numbers is the average atomic mass, which you can also use it as the mass number. The number of protons is equal to the atomic number. It's always like that. So because helium has an atomic number of 2, it has 2 protons. The number of neutrons is equal to the mass number minus the atomic number. And the number of electrons is equal to the atomic number minus the charge. So an atom, which is electrically neutral, which doesn't have a charge, atoms have equal number of protons and electrons. But ions, they differ in their number of electrons and protons. Ions have unequal amounts of protons and electrons. Now, an isotope of helium can be written this way. Sometimes you might see it like this. The top number represents the mass number. The mass number is usually the larger of the two. The atomic number is the smaller one. So if you see it this way, just know that the mass number is on top. But if it's written on a periodic table, the top number is usually the atomic number. Whichever one is lower is the atomic number. The higher one is the mass number. So don't get confused about that. Helium, which we said has 2 protons, it also has 2 neutrons. And as a neutral atom, it has 2 electrons. So if we draw the atomic structure of helium, it has 2 protons, which I'm going to represent it with a positive charge, and 2 neutrons. The neutrons are neutral, but protons have a positive charge. And surrounding the helium nucleus, you have 2 electrons. Now, opposite charges attract. Opposite charges, they feel a force of attraction that pulls them together. And like charges, they repel. So these two charges, they feel a force that pushes them away from each other, known as the electric force. So now what about the 2 protons within the nucleus of an atom? They feel an electric force that pulls them apart, but yet they remain intact. Therefore, there must be another force that keeps them intact. The force that holds the nucleus together is known as the strong nuclear force. And so that's why the protons, they don't repel each other. Now, a common question that you might see in chemistry is you need to be able to determine the number of protons, neutrons, and electrons inside an atom or an ion. So let's say if you have the aluminum atom, which has a mass of 27 and the atomic number of 3, and also the aluminum ion, which has a charge of +3. Go ahead and determine the number of protons, neutrons, and electrons in these two particles. So the atomic number is the number of protons. So both the atom and the ion has 13 protons. The number of protons identifies the element. Now what about the number of neutrons? The neutron number is the difference between the mass number and the atomic number. So 27 minus 13 is 14. So both the atom and the ion, they have the same number of neutrons. Now what about the electrons? The electrons is the atomic number minus the charge. So this is going to be 13 minus 0. So therefore an aluminum atom has 13 electrons. An aluminum ion, it's going to be 13 minus 3, which is 10. So the aluminum plus 3 cation contains 10 electrons. Positively charged ions are known as cations. Negatively charged ions are known as anions. Now, if you add the 13 protons and the 13 electrons, you get a net charge of 0. So atoms are neutral. But for the ion, if you add the 13 protons with the 10 electrons, which has a negative charge, 13 plus negative 10 is positive 3, which is the net charge of the ion. Try these two. Phosphorus 31 and also the phosphide ion. Calculate the number of protons, neutrons, and electrons. So the atomic number is 15. Therefore, both of these have 15 protons. To find the neutron number, it's going to be 31 minus 15, which is 16. So both the atom and the ion has 16 neutrons, but they're going to differ in the number of electrons. The electron number we said was the atomic number minus the charge. So 15 minus 0 is 15. So therefore, the phosphorus atom contains 15 electrons. Now the phosphide ion is going to be 15 minus negative 3. Whenever you have two negative numbers or two negative signs next to each other, the negatives, they will cancel and turn into a positive number. So it's really 15 plus 3. Therefore, an ion with a negative charge has more electrons than protons. So we have 15 protons, which has a charge of 15, and 18 electrons, which has a net charge of negative 18. 15 minus 18 gives you a net charge of negative 3. So whenever you have a positively charged ion, it tells you that that ion has more protons than electrons. If you have a negatively charged ion, that ion has more electrons than protons. Now let's focus on carbon. What are isotopes? Let's consider the carbon-12 isotope and the carbon-13 isotope. Isotopes are composed of the same element. So carbon-12 and carbon-13, these are isotopes of each other, but chemically, they behave the same way. Their chemical reactivity is exactly the same. However, their nuclear properties are different because the nucleus of carbon-13 is different than that of carbon-12. Both of these atoms contain 6 protons, and the number of protons, or the atomic number, identifies the element. So any substance with 6 protons is going to behave as a carbon atom. Now the number of neutrons is the difference between the mass number and the atomic number. So carbon-12 has 6 neutrons, but carbon-13 has 7 neutrons because 13 minus 6 is 7. Now as an atom, they both contain 6 electrons. So now let's analyze carbon-12 and carbon-13, which are isotopes of each other. So as you can see, isotopes are composed of the same element, in this case, carbon. Now, because they're made up of the same element, they have the same atomic number, in this case 6, and they also have the same number of protons. So that's the similarities between isotopes. Isotopes differ in two things. They differ in the mass number and in the number of neutrons. So make sure you remember these facts. So isotopes have the same number of protons, same atomic number, and is composed of the same element. Isotopes differ in the neutron number and in the mass number. Now, if we check out the symbol for carbon, and if you look at the periodic table, you'll see a 6 above it, and below it 12.01. This number is not exactly 12. Why is that? Why is it 12.01 and not 12? This number is really called the average atomic mass. Why is it called the average atomic mass and not simply the atomic mass? Keep in mind, carbon has multiple isotopes. The predominant isotope is carbon-12, but you also have carbon-13 and a very, very tiny amount of carbon-14, but mostly carbon-12 and carbon-13. Approximately 99% of carbon atoms in a sample is carbon-12, and the other 1% is carbon-13. The amount of carbon-14 is insignificant, so we're not going to worry about it here. So what this means is that if you have 100 carbon atoms, 99 of those carbon atoms is going to be carbon-12, which means they have 6 protons, 6 neutrons. Now, out of those 100 atoms, at least one out of those 100 carbon atoms is going to be carbon-13, where it has 6 protons, 7 neutrons. It turns out that this mass number is a weighted average of these two isotopes. And the way to calculate a weighted average, in this particular instance, you need to multiply the mass by the respective percentage and add it up. You got to find the sum. So the average atomic mass is going to be the mass of carbon-12 times its percentage in the form of a decimal. 99% is 0.99 as a decimal. You simply take a 99 and divide it by 100, or you can move the decimal 2 units to the left. So it's going to be 12 times 0.99 plus 13 times 1%, which is 0.01. 12 times 0.99 is about 11.88, and 13 times 0.01 is 0.13. When you add these two numbers, you're going to get the average atomic mass of 12.01. So that's how you can calculate the average atomic mass of an element. You have to take the weighted average of all the isotopes that are found in nature and make sure you multiply it by their relative percent abundance. Try this example. Boron has two principal isotopes, B10 and B11. Approximately 81% is B11 and 19% is B10. Using this information, calculate the average atomic mass of an atom of boron. So the average is going to be the mass of the B10 isotope, which is 10, multiplied by the percentage as a decimal. 19% is 0.19. And isotope B11 has a mass of 11 and a relative percent abundance of 0.81 as a decimal. So 10 times 0.19, that's about 1.9, and 11 times 0.81, that's 8.91. So if you add these two numbers, you're going to get the average atomic mass of an atom of boron, which is 10.81. Now, sometimes you may have to work this problem backwards. Sometimes you may want to calculate the relative percent abundance of each isotope. Consider chlorine. Chlorine has two main isotopes, chlorine 35 and chlorine 37. If you look at the periodic table, the average atomic mass of chlorine is 35.45. Now, knowing that, do we have more of the Cl35 isotope or the Cl37 isotope? Which one is more predominant in nature? Because the average is closer to 35 than it is to 37, that tells us that chlorine 35 is more abundant in nature than chlorine 37. So how can we calculate the percentage for each? Now, if you remember in the example of carbon, 99% was carbon 12, 1% was carbon 13. But these two numbers have to add up to 100. 99% is 0.99, 1% is 0.01. So let's say if 0.99 was x, that means that 1 minus x is 0.01. 1 minus 0.99 is 0.01. So to find the percentage, you need to use x and 1 minus x to solve it. So let me illustrate. Let's say if we want to find the relative percent for Cl35, it's going to be 35 times x. For the other isotope, it's simply 1 minus x. So we just got to solve for x. So we have 35x. Here we're going to distribute the 37. 37 times 1 is 37. And 37 times negative x is negative 37x. So at this point, let's combine like terms. 35x minus 37x is negative 2x. So what should we do next at this point? We need to get x by itself, so we got to move the 37 to the other side. So let's subtract both sides by 37. So these two will cancel. On the right side, we have negative 2x. On the left side, 35.45 minus 37 is negative 1.55. I'm not sure what just happened there. So now let's divide both sides by negative 2. So negative 1.55 divided by negative 2 is equal to x. So x is 0.775. Keep in mind x was associated with Cl35. 0.775 is 77.5%. Keep in mind, to go back from a decimal to a percent, you need to multiply by 100, or move the decimal point 2 units to the right. Now, 1 minus 0.775 is 0.225, which is 22.5%. So that's the relative percent of chlorine 37. So if we have 1,000 chlorine atoms, in this sample, how many of those atoms would be chlorine 35 and how many is chlorine 37? So out of 1,000 atoms, 775, would represent chlorine 35. The other 225 would represent Cl37. So out of 1,000 atoms, 775 of those atoms is the chlorine 35 isotope. The other 225 is the chlorine 37 isotope. So that is it for this video. That's all I got. Hopefully you found this video to be educational. So thanks for watching and have a great day.